Alright, I'm presenting this video to help you in writing a quadratic equation in vertex form. We've been graphing quadratic equations in vertex form and finding information out. The axis of symmetry, zeros, y-intercept. We have strategies for that. What I would like to have presented on video for you to refer back to at your leisure is on the back of the buff colored sheet that we use to review vertex form in class on Wednesday. There is an example of writing a quadratic function for a parabola in vertex form, y equals a times the quantity x minus h squared plus k, and we know that the vertex of this parabola sits at h comma k. We've been able to pull the vertex information out from the equation, but what we want to do now is, given a vertex and a point on our parabola, we want to be able to write an equation in vertex form. So what we'll do it's going to be our example. You have example 1 and 2 worked out for you on this page. 1 and 2, we'll talk about this more in class. But I'd like to work out example 3 in front of you so you have an idea how to tackle these types of problems. Write a quadratic function in vertex form for the function y equals a to, I just wrote it, but I'm going to write it again, whose graph has its vertex at negative 5 and 4. That will be my h and k pair, and passes through the point 7 and 1. So right now I have the h and k that I would put into this equation. The problem is we need to figure out what that a value is. We need to find out if this parabola is going to open up or down and how it stretches or shrinks. So what we'll do is use this point x and y and substitute it into our equation, because if we put this xy point in, x is 7 and y is 1, that'll leave us, we'll have an x to put in the equation, we know our h is negative 5, we'll have a k to put in the equation, and we have a y value that we can put in the equation over here. The only thing remaining to solve for will be our a. So I'm going to start doing that. I'm going to do it kind of right underneath here. Y equals, the y value I have is 1, so 1 equals, our a is the missing piece. X, the x value I can use is 7 from this ordered pair. X minus h. H is our negative 5. Our vertex sits at negative 5, 4. So it's going to be 7 minus negative 5, which is actually going to result in 7 plus 5. We'll square that amount. Then we'll add the k, which we see to be 4. So now I'm going to go through and I'm going to solve this equation. I'm going to add 7 and 5. That's 12. I'm going to come back and square that here in a minute. 1 equals 12 times 12 is going to give me 144. So I'm going to replace 12 squared with the value 144. I'm just going to rearrange it though. I want it to read 144 times a rather than a times 144. We're used to seeing the variable at the end. I'm going to add 4 to both sides, or I'm going to add 4 to finish out writing my equation. And then my next move is going to be to start undoing to solve for a. I'm going to subtract 4 from both sides, and I'm going to get negative 3 equals 144 times a. And in order to get a alone, I'm going to divide both sides by 144. A will be equal to, it's going to be a pretty small decimal number, I think, negative 3 divided by 144, which is negative 0.021. That's an approximation for a, but I can use it. Now I'm going to go back into my equation and I'm going to put the things that I need. I'm going to put in my a and my h and k, and I'll have an equation written for this parabola. I'm gonna leave behind the x and y pair I used. I used it to get the a that I wanted. Y is equal to negative 0.021 times x minus h, which is going to be x minus negative 5, so x plus h squared plus k. Y equals negative 0.021 times the quantity x plus 5 squared plus 4. There's another example for you how to write an equation for a parabola or quadratic function in vertex form. Good luck.